Right, so moving on to that last page there. So just like we work with graphs pretty much throughout this whole course, so you know what, let's look at this graph of our inverse function or our logarithmic function. So last but not least, let's look at that graph of the exponential function and its inverse. So here is an example. So here we have the graph of y is equal to 2 to the power of x. So that's the exponential function. And so here we need to state the inverse of the function and identify any following characteristics of that graph. So here I've labeled it, that are kind of written down what I all expect from you guys. So first, to start off, let's write that. What is that inverse function? So here, if you guys remember, we switch those x and y values. So we're going to have x is now equal to 2 to the power of y. That's going up to that first page, so changing it from an exponential function to its inverse, you switch that x and y, so your y becomes the exponent, and then x takes that y value place. So first we're going to graph it, and then we're going to talk about the characteristics that it has, okay? So I'm just going to scroll on down there. Alright, and we're going to create a table of values. So one thing that's going to be a little bit different here is that we're going to be choosing y values. Wow, okay, we're going to be choosing y values instead of x values. So our inverse that we had was x is equal to 2 to the power of y. And why are we going to choose y values instead of x? Well, if we had x values, we're going to have some variable as an exponent, and we don't want that. So let's choose y values. It'll make life a lot easier. We won't have to do any complicated solving. So it'll work wonderfully and much more simply if we just choose our y values. So for that one, let's just choose, your typical values that you would choose for any graph. So let's go with -2, -1, 0, 1, and 2. Let's just pick those ones at random. And then we're going to plug y in, or all those y values in for y, and we're going to solve for x. So we'd have 2 to the power of -2, which is equal to 1 over 4. Then we have 2 to the -1, which is equal to 1/2. 2 to the 0, which is equal to 1. 2 to the 1 is equal to 2. And last but not least, we have 2 squared is equal to 4. So you guys can do this graphically using your graphing technology, or if not, you guys, it would be maybe some good practice to try this one out on your own and do this one by hand. So now let's graph these values here. So I'm going to move on up to our graph here. Alright, so our first value there, we had y is equal to -2, so y is equal to -2, and x is equal to 1/4. So if you guys notice here, this is 1 here, so our 1/4 is approximately about maybe right there. And then we have y is equal to -1, that's -1 is about here, so -1 and 1/2, so our value might be around there. Then we have y is equal to 0, so that's when it crosses that x-axis. So at 0, your x value is at 1. Then we have y is equal to 1, and x is equal to 2. And our last point, we have y is equal to 2 and x is equal to 4. Okay, so just a little bit different. I know it's a little bit trickier because normally we would graph, or we'd find our x values. So just remember, find your y values, so y is at -2. Not, I know that even I was running into that problem. I would keep graphing. I'd look for x is equal to -2, and I'd work it that way. So just remember, you chose y values, so y at -2 is, x is at 1/4, okay? So from there we can connect our little dots there. If I can connect them very nicely. Hopefully you guys can do a better job than I can on my wonderful graphing. My graphing skills are just fantastic. Okay, so from there, maybe I'm going to, since this just looks absolutely awful, I'm going to quickly grab my graphing calculator and do a screenshot of that. Alright, how does that look? Probably a whole lot nicer there, so we can kind of see a little bit more of some of the key things that are going on here. So just remember, ladies, that we do need to label, especially when we have more than one graph on, or more than one function on the same graph. So we need to label this. We have x is equal to 2 to the power of y here. We have y is equal to 2 to the power of x over here. So then let's talk about, let's go to our characteristics. So the first one here, we're looking at our domain and the range. And so looking at that there, oops, wow, okay. My little writing pad here is working wonderfully today, if you guys couldn't tell. So here, our first one here is our domain. So we have x such that x. If you guys look, your x values, it kind of looks like it kind of goes along that same line as with our exponential function. That it does have a like kind of like a little like a line that it can cross. So it has a what we would call a vertical asymptote. So our x values, and if you were to keep extending this graph, it would never actually touch that y-axis. So what we'd say here is that x such that x must be greater than 0, where x is an element of all real numbers. So it's just like looking at, say, with our exponential function, so not the inverse one. So here it couldn't cross that x-axis, so y couldn't, or y had to be greater than 0. So in this case, because we switched that x and y, that's why now it can no longer cross that y-axis now. So it kind of has that flipped domain. So then if you guys look, your range, now it's the opposite. So now we have y such that y is an element of all real numbers. So y can be anything from -infinity to infinity, so y is an element of all real numbers. So if you guys compare that to your exponential function, normally your x values would be as an element of all real numbers, and then your y values would have that restriction where it must be greater than 0. But since we flipped it, we had that inverse, so now that's going to change. So we have kind of the opposite of what was going on as before. Okay? So then, they also want to know is, what is your x-intercept, if it exists at all? So looking at that, where does it cross that x-axis? And we even had that one nicely in our table of values. So that is when we are at 1 and 0. Then, looking at using a graph, we can find our y-intercept if it exists. And that's kind of going back along the lines of our domain there. So it will never ever cross y is equal to 0. So it means that none exists. So if you guys want to even compare that to your inverse and your exponential function, so when we had y is equal to 2 to the x, we had that where we didn't have an x-intercept, but we did have a y-intercept at 1 and 0. So that'd be right here. But then we switch that. So with that inverse, that kind of switches those values there. So now we have an x-intercept and we don't have a y-intercept. So kind of switch those two little values there. Okay? And then the last one there, so we have the equation of the of any asymptote. So once again, so it's kind of similar to when we had our exponential function. Normally there we had our asymptote was usually at x is equal, or y is equal to 0, sorry. So now, because we flipped it, now we're going to be using our x values. So now x is equal to 0 is our new asymptote. So it's kind of, your inverse and your exponential form are basically like, they're the opposites of one another. So when x had an element of all real numbers, when we took that inverse, your y values became that value with all real numbers where there was no restrictions. So same with your x and y intercepts. So those basically did a swap. So now now we do have an x-intercept, and now we don't have a y-intercept, okay? And I just want to ask you ladies, just before I set you loose on your assignments, so why do you think I included, if you guys look at this, oh boy, okay, wow. So why do you think I included this line here? So that is that y is equal to x. Why do you think I included that? Okay. So I'm just going to say here, if you guys look at those values, so this is going to go kind of along the same lines of what I was getting at with these characteristics, is that this line, y is equal to x, so this line y is equal to x is kind of acting like a mirror. So essentially our exponential function, it's going to be, I guess, a mirrored reflection from our inverse function. So or I guess we could say the inverse function is the reflection of your exponential function over this y is equal to x line. Okay? So that's if you guys want to look at those values. So here we have 1 and 0. So it did that mirror from 0 and 1. Then we could say, let's look here. So here x is at, we're at 1 and 2. Then if we go to this point here, we're at 2 and 1. So notice how those kind of swap there compared to your original function. So that y is equal to x kind of acts as like a mirror line from your inverse function and your exponential function. Alright, so now I'm going to set you loose on your homework there, ladies. So that's it for today's lesson. So we'll be back again tomorrow.